Alright, now all the fluff's done. We already learned all of the standard forms of all of the conics. We learned everything about all of the conics. Now we're going to apply everything we learned. So, we want to be able to write the equation of conic given the graph of the conic. Alright, what should we do first? We'll identify the conic. So first I see that this is a parabola. Good. I see that I have a directrix here. This is the line y equals 5. So, what else do I see? I have my vertex. And I know that it's opening down. So if the parabola is opening down, it is going to be an x squared parabola. So it'll be of the form x minus h squared equals 4p times y minus k. But since it's opening down, the p-value is going to be negative. What is the p-value? Well, if the vertex is at the point 2, 3, and the directrix is the line y equals 5, the p-value must be 2. In this case, it's going to be negative 2. And I know that because that is the distance from the directrix to the vertex, and I know it's negative because it's opening down, so therefore my answer will be x minus 2 squared equals negative 8, 4 times negative 2, times y minus 3. So, that's what we do. We take the information that we see, we pull out any key information we can, and we write the equation of the conic. Given the equation of the circle, I want you to, given the picture of the circle, I want you to write the equation of the conic. Pause the video, do this on your own, unpause when you're ready to check your work. Alright, so hopefully you identify this is a circle, which we talked about anyway. The center is the point negative 1, negative 3, so I'm going to have x plus 1 squared plus y plus 3 squared. And then from there I go every direction a distance of 4, so the radius is 4, therefore the radius squared is 16. So my answer is x plus 1 squared plus y plus 3 squared equals 16. You should have the equations of the conics in standard form in front of you that are in your packet as you're doing this so that you can reference those. You do not need to memorize them. Okay, what do we have here? Here we have an ellipse. It is stretched vertically. I don't really care about that much as long as I understand that the larger number is going to go under the y squared term because it is stretched vertically. So, what can we do here? We'll do this one together. Identify the center. The center is right here. What is the x value? It is 2. What is the y value? It is negative 3. So this is going to be of the form x minus h squared over b squared plus y minus k squared over a squared equals 1. Again, don't focus so much on what is a and what is b. Think more about what is the distance from the center up and what is the distance from the center to the right. Those are going to be the numbers that go under the y squared and under the x squared term respectively. So in this case, I know that I have x minus 2 squared plus y plus 3 squared equals 1. Well, how far up do I go? If I go from 2, negative 3 to 2, 2, that went up a distance of 5. So this number here is going to be 5 squared. If I went from 2, negative 3 to 5, negative 3, I went to the right 3, so that is going to be b, so b squared then will be 3 squared, or 9. Here we have a hyperbola. I want you to try this one on your own. Here you're going to have to use the relationship between the foci and the center along with the major vertices and the center to help write the equation of the hyperbola. Also notice that it is opening up and down. Therefore, you know that the y squared term is going to be positive and the x squared term will be negative. Pause the video, try to write the equation, unpause when you're ready to check your work. Alright, so your answer here should be y minus 1 quantity squared over 9 minus x plus 3 quantity squared over 7 equals 1. How do we come up with that? Well, again, we talked about before you pause the video that this was opening up and down, so I know it's a y squared first and then an x squared. So the x squared term will be the minus. So I wanted to find the center. We'll just find what point is in between the two vertices. So if this is at negative 3, 4 and this is at negative 3, 2, then negative 3, 1 is the center. So that's how I came up with the y minus 1 squared and the x plus 3 squared. Alright, then I need to find the values that go underneath the y squared and the x squared term. Well, under the y squared term, since this opens up and down, is going to be the distance from the center to the vertices. So from the center to the vertice is a distance of 3. So a, in this case, again, don't focus so much on a, just think about it, it's the number that goes under the y term because it's opening up and down. A is 3, so a squared is 9, so this value is 9. Now, from the center to the foci is a distance of 4. So that's my c value. So I know c squared is 16. For a hyperbola, I know that a squared plus b squared is c squared, so I can solve this equation for b squared. Notice that I never even found b. I don't really care about b in this case because all I'm trying to do is write the equation of the hyperbola, and the equation involves b squared. Moving on. Now we'll do a little more challenging problem. So here we want to graph the following conics. So the first thing you need to do is actually identify the conic. So here if I have an x squared, y, an x, a constant, and a y squared, bring everything over to one side first. So actually I would write this as x squared minus 10x plus y squared minus 6y, and then bring the constant over to the other side, equals negative 25. So therefore, I know sorry about that, negative 25. I know that this is going to be a circle. I know that because I have 1x squared, 1y squared. Same coefficient, same sign. Okay. Now that I know that, I can go ahead and complete the square. I know what I'm trying to get this to look like so that I can graph the circle. Half of 10 is 5. 5 squared is 25. Add that to the other side. Half of 6 is 3. 3 squared is 9. So now I can factor, and this becomes x minus 5 squared plus y minus 3 squared equals 9. So I know that I have a center at 5, 3. And a radius of 3, since the radius squared is 9. And then we draw a perfect circle. So here, I want you to try this one on your own. I will give you a hint. It's set up pretty easily for you to recognize at least what the conic is. So try this one on your own, get it in standard form, graph it, and all of the key features. Pause the video, unpause when you're ready to check your work. Alright, so here we hopefully recognize that this is going to be a parabola. So the first thing I did was I just multiplied everything by 4 to get rid of the 1/4. So 4y equals x squared minus 2x plus 5. I subtracted 5 to the other side. I rewrote it with the x's on the left and the y on the right. It doesn't matter. So I have x squared minus 2x equals 4y minus 5. I wanted to complete the square with the x's, so half of 2 is 1, 1 squared is 1. Add that to both sides. Factor this into x minus 1 squared, factor out a 4, I get times y minus 1. So I know my vertex is the point 1, 1. I can graph that. The p-value is going to be 1, since 4p is 4. It's positive, the x is squared, so it's going to open up. So my focus is going to be the point 1, 2, and the directrix is going to be the point, or is going to be the line y equals 0. What do we have here? Well, I see that I have an x squared and a y squared, and they have opposite signs. So therefore I know that this is going to be a hyperbola. So I want you to try to get this in standard form and then graph it. We know that the x squared term is positive and the y squared term is negative. So we know that this is going to be a horizontal major axis hyperbola. Pause the video, try to do that on your own, unpause when you're ready to check. Alright, so here our graph should look like this. For our hyperbola, the standard form of the equation we have is x minus 2 Conic squared over 1 minus y plus 3 Conic squared over 9 equals 1. So I know my center is the point 2, negative 3. The c value comes out to be 9 plus 1, which is 10, so that's c squared, so c is the square root of 10, so my foci are at 2 plus or minus root 10, comma negative 3. This gets added and subtracted to the x value of the center because the hyperbola opens to the left and to the right. Keep in mind, in this picture, the black curves are the only actual part of the hyperbola. Everything else is just used to graph it. The black dots are the foci. The asymptotes are the lines y plus 3 equals plus or minus 3 times the quantity x minus 2. We get that because the point 2, negative 3 is the center, and the asymptotes go through the center, and the slope from the center I go up 3 over 1, and I go down 3 over 1. So the one of them has a slope of positive 3, one of them has a slope of negative 3. Now let's look real quick and see how we got the standard form if you were confused on that. Group the x's, group the y's, bring the 18 over, factor out a 9 from the x's, complete the square by adding a 4, which means I'm actually adding 36 to the right hand side. Factor out a negative 1 from the y's, complete the square by adding 9, which means I'm actually subtracting 9 from the right hand side. Factor, factor, combine like terms, divide everything by 9, and that is how we end up with our standard form. Last one. Again, I want you to try this on your own. Identify the conic, get it in standard form, graph it. Pause the video, unpause when you're ready to check your work. Okay, so here we get a tiny little ellipse. The standard form of the equation is x minus 2 quantity squared over 1 plus y plus 1 quantity squared over 9/4, and this equals 1. So then we have a center of 2, negative 1. So I plot my center. My b value is the square root of 1, which is 1. My a value is the square root of 9/4, which is 3/2. So from the center I go left and right 1, up and down 3/2, or 1.5. The c value, c squared, comes out to be 5/4, so c is the square root of 5 over 2. So I add that to the y value of the center. So the foci are at 2, comma, negative 1 plus or minus root 5 over 2. How do I come up with this? I recognize that it's an ellipse because I have the same sign but different coefficients in front of the x squared and y squared. So I group the x's, I group the y's. Factor out a 9 from the x's, factor out a 4 from the y's. Complete the square with the x's, so I add 4 in the parentheses, which means I add 36 to the other side. Complete the square with the y's, so I add 1 in the parentheses, which means I add 4 to the other side. Factor, so this becomes x minus 2 quantity squared. This becomes y plus 1 quantity squared. Now, when I divide by 9, 9 divided by 9 is 1. When I divide this by 9, I end up with 9/4 in the bottom. We actually have, what happens is we end up with 4 over 9, but the 4 is still in the numerator, so to write that as just a denominator, we have to write it as 9/4. If you're confused on that, an example would be, or exactly what's happening, I guess I should say, is 4 over 9 is the same thing as 1 over 9/4. And this is essentially how we're writing the answer, because although we don't write it, there's a 1 still here in front of this parentheses. So that's how I end up with that. Alright, so when writing the equation of a conic from the graph, identify the key features and just plug them into your standard equation. When graphing, first get it into standard form so you can pull out the key features and then graph it.